Hi everyone, this is Ware. Welcome to my channel. Today I would like to introduce my third programming learning project, making a Candy Crush using pygame. First, let's take a look of my Candy Crush. There are three different windows in my game. Window 1, Start window. It contains welcome messages. Window 2, Game playing window. It is the main platform of the game. The game board is on the right. On the left, it is the scorebar, containing target candies and the remaining moves. Window 3, Game Over window. It displays message you win or you lose, and asks if the player wants to start again. And I want my three windows to run like this. When starts the game, it shows window 1. When the player press Enter key, it starts window 2, and the Candy Crush starts running. When the game over, it starts window 3. When the player click Play Again button, it starts window 2, the game starts again. Anytime during the game, if the player press Escape key or click X on the window, the program terminates. Now let's break down each window. First, let's look at window 1. Window 1 is a 1100 x 800 pixel screen. It contains two messages. When the player presses Enter key, the program enters window 2. To enhance the visual appeal of the game interface, I specifically created a custom background image with a light pink tone as the main theme, adding a touch of cuteness. Next, let's look at window 2. Window 2 is the main body of the game. It contains two blocks, game board, and scorebar. First, let's look at the game board. The game board is a 6x6 matrix, forming 36 cells. Every cell can carry one candy. There are in total 6 types of candies: red, orange, yellow, green, blue, purple, generated randomly. I would like the game to support the following interactions. First, the player clicks to swap two adjacent candies. It displays candy swap. 2. The swap results in 3 or more candies aligned in a row or column. This is checked by the function find matches. 3. The aligned candies are eliminated. 4. The empty space left by eliminated candies are filled by candies falling down from above. 5. The empty spaces at the top will then be filled with newly generated random candies. Next, we're going to introduce every step's coding logic. First, swap. The pseudocode of this step is as follows. First, I define start cell and end cell. Start cell is the position where the mouse is pressed down. End cell is where the mouse is released. I created a function called getCell to get the position of mouse click. Next, I check whether two positions are adjacent. For this, I designed a function called rNextDoor to handle the adjacency check. If the two positions are adjacent, I call animateSwap to display the animation of the two candies being swapped. So this code block is running like this. First, the mouse clicks down on the first candy. getCell records the click down position and stores it in start cell. 2. The mouse moves to the second candy and release. getCell records the click up position and stores it in end cell. 3. Use rNextDoor to determine whether start cell and end cell are adjacent with each other. 4. If true, run animateSwap to exchange two candies. Now let's move on to the second step, match. The pseudocode of this step is as follows. I designed the find matches function to scan all 36 cells of the game board and check whether there are 3 or more candies aligned in a row or column. If a match is found, the game proceeds to the next step. If no match is found, Anime swap is used to swap the candies back to their original positions. So this code block is running like this. 1. If fun matches detect 3 same candies in a row, proceeds the following steps. 2. If no matches detected, use anime swap to swap candies back. Now let's move on to the following steps. 3 to 5, remove, drop, refill. Steps 3 to 5 form a repeating loop. That is, once matched candies are eliminated, the game automatically enters the next round of detection using fun matches. If the newly updated board contains 3 or more aligned candies, the sequence of remove, drop, refill must be executed. The sequence continues to loop until no more matches are found. If there is no aligned candies, the loop exits. To implement this continuous process, I created a function called resolve game board, which wraps steps 3 to 5 inside it. The pseudocode of this function is shown on the left. This code block is running like this. Start a while loop to continuously check whether there are any matched candies with findMatches function. If matches are found, they are stored in the variable matches. If no matches are found, the loop ends and exits resolve game board. Once the scan is complete, if the loop has an end, it means that there are indeed matched candies. Then the sequence of remove, drop, refill must be carried out. Specifically, 1. Eliminate the matched candies using remove matches. 2. Redraw the game interface using draw game board to show that the matched candies have been removed and empty spaces have appeared. 3. Let the candies above fall down to fill the gaps using animate gravity. 4. Randomly generated new candies to fill the remaining empty space using refill game board gravity. 5. Redraw the game interface again using draw game board to show the fully updated board after filling is complete. In the main loop, I only need to call this resolve game board function once to automatically perform the entire process of repeatedly scanning for matches and filling the board with falling candies. These are the introduction of the game board. Next, let's look at the scorebar. The scorebar is divided into 3 sections: top, middle, and bottom. The top section displays the remaining number of moves for the current round with an initial value of 12. The middle and the bottom section show the 2 target candies and the number of each type needs to be cleared. The target candies have randomly selected for each game round, and none of each type must be eliminated. The above is the overview of Window 2. Now let's move on to Window 3. Window 3 displays the scoreboard, and depending on the game result, it selectively shows either you win or you lose. It also includes a Play Again button, which allows the player to start a new game when clicked. So this is how I made the Candy Crush. Comparing with my first and second projects, Snake and Tetris, Candy Crush definitely has more complexity, but of course with more fun for learning the design and implementation, and finally successfully make it out. For the complete source code, I have put them on the GitHub. I have attached a link for the scripts in the info box below. You should be able to run the program if you install the pygame properly. I also attach a link for the pygame installation as well. Hope you enjoyed the video and see you next time.